Hello everyone, my name is Madushan Gamage. Uh, I'm pre-recording this talk from Singapore, and I'm really excited to talk to you today. And I'm really thankful to the amazing organizing committee for this opportunity. So today we are going to talk about the journey from CocoaPods to Swift Package Manager.
You might be wondering, what about Carthage? What if you have Carthage as your dependency manager in your project? Don't worry, you will definitely have something in this.
Swift Package Manager actually came as a surprise when Apple open source Swift in 2015. At the time, people thought Apple has Sherlock CocoaPods, but did it Sherlock CocoaPod? No, CocoaPod still exists, and it is still the number one package manager out there. I think it's interesting to understand this third-party dependencies landscape today, as well as how dependency managers are used among the iOS developer community. So
I fetched few questions from this developer survey last year. Let's look into a few of them. The first one is about dependency management in general. So the question was, how do you approach code dependencies in your app?
vast majority of people believe a few carefully selected high-quality libraries are fine to use. And some people believe the number of libraries is not important as long as they're high quality. And there is some 20% of the folks believe that party dependency should be avoided whenever possible. But the general signal here is third-party dependencies are used widely. So when it comes to third-party dependency management in the business apps, so how and which dependency managers will use? As you can see, the CocoaPods is dominant number one, 74.8% of the participants is using CocoaPods for their business apps. And Carthage is the second, manual management is close third, and Swift Package Manager is fourth. It is picking up. So what's the takeaway from those two slides? CocoaPods is the number one most popular, and Swift Package Manager is picking up. So that's why I decided to focus this talk today about transitioning from CocoaPods to Swift Package Manager. So in this talk, we're going to talk about mainly four things. We're going to look into where Swift PM stands today, and how to migrate to SVM from CocoaPods, and what limitations Swift PM has. And we're going to look into the future. So the main idea, the main takeaway that I want everyone to take from this talk is to make an informed decision about this transition and understand the limitations, understand what it can do as well as what it cannot do, and make an informed decision. Let's try to understand what is Swift Package Manager. So Swift Package Manager is a tool for managing the distribution of Swift code, and it is integrated with the Swift build system to automate the process of downloading, compiling, and managing dependency. So it is a package manager as well as a build system. It's not just a package manager. It has a build system because that was the only solution that Swift on server community had at the beginning. So they could only build using Swift package manager. So the primary focus of the Swift package manager was highly targeted to as a server-side Swift at first because they didn't have any other choice. iOS and iOS platform has Xcode and CocoaPods and other third-party dependencies management tools. So let's try to understand how this dependency managers works in general. CocoaPods actually do both of these things. It does the dependency management and it does the Xcode integration.
Let's have a brief look into how each dependency manager or the package manager fill in these responsibilities. Number one is Carthage.
So Carthage, of course, does this dependency management part. It does this dependency management a little bit differently. So unlike CocoaPods, it actually by default build those target using export build as well, and then put all the pre-built rendered frameworks inside a specified location. So it is your responsibility to integrate them back to export, because it doesn't do this export integration. Because Carthage wanted to be simple as possible, and as well as not to have other dependencies like frameworks or libraries written in other language. Because as you may already know, CocoaPods is written in Ruby, and it is actually a whole package of bunch of Ruby gems working together to give you this dependency management. But Carthage is written in Swift, and it saves you from depending on like Ruby or gems or Ruby version managers. Because if you want to use CocoaPods today, right, you need Ruby version manager as well, because CocoaPods has dependency into Ruby language and our version requirement. And to manage these Ruby versions, you need a Ruby version manager as well. So it can be RBNV or Rwin. So, and then you need Ruby set of Ruby gems, which includes CocoaPods and the bundler. So generally the idea is CocoaPods require a set of Ruby layer as its dependencies, but Carthage don't need that. It is simple, it is written in Swift. But Carthage has this interesting use case that you can use today. You may have heard about this tool called Xcode Gen. This actually lets you define your Xcode project using YML and then generate the Xcode projects using this YML. So this helps you to get rid of Xcode projects being added to your version control system, because you know that these project files are frequent source of merge conflicts, and it's hard to resolve these merge conflicts because this project file format, I mean, I don't need to say that you already know this, how painful this project file format sometimes. So you can get rid of them using this tool. And this actually, this even supports Swift package managers. And you can specify Carthage dependencies here and then use them.
So where does SPM sit? So SPM does the dependency management, but it doesn't do the export integration. What? Yeah, it doesn't do the export integration, but it does a different job. It helps you to generate the Xcode project from a Swift package. So if you want to integrate them, it has to be manual, right? Because today, if you want to use a Swift package, if it's an internal package, you need to drag drop into the Xcode project. Or if it's external package, there is a UI that you specify the URL and ask Xcode to find this package and download. So SPM does different job when it comes to Xcode integration. It generates the Xcode project. So it has a tool to generate Xcode project. Using one command line utility, you can type Swift package generate Xcode projects. It will generate Xcode project for you for your package. But this is deprecated in favor of this alternative. The alternative is to simply open the package manifest file in the terminal, and it will open the whole package in Xcode environment. Then you can work on top of that on Xcode. I think this is where this the package manager and the Xcode integration goes. So this is a kind of future. You open the package and then you have Xcode project. So SPM actually does another job than the first two responsibilities we described, dependency management and Xcode integration. SPM is a build tool as well. So if you check how it works behind the scene, so there's this Swift package called llbuild. It is a Swift package, but it's written in C++ mostly. So it's a framework for building build systems. You can use that framework to build your own build system, because this framework has as any other framework, this framework has an interface, an API that you can use to perform build tasks. And this communication happens via YML file. So as long as you can generate this YML file, which contains the specific instruction that is required to build something, you can hand this YML file to LL build and ask to perform this action. So today, all the build tools, Swift Package Manager, Xcode, and Xcode build command line utility, all of them are backed by this LL build. So let's look at how to migrate. How to migrate from CocoaPods to Swift Package Manager. So to perform this migration, of course, you have to move all your CocoaPods to Swift packages. To perform this migration, you have to make your pods and convert them to Swift package. So Swift packages are defined as these pod spec files. Swift packages are defined using this Swift package manifest. It is an API available in this package description module. So you need to do this conversion for all some pods that you want migrate to Swift PM. So let's try to look at different scenarios you have today when you're doing this migration. You might have different kind of CocoaPods. You might have local CocoaPods. You might have external CocoaPods. You might have source-based CocoaPods or vendor binaries, different pods. So this mind map kind of summarizes what you need to do to migrate different kind of pods to Swift packages. So let's try to walk through a few of them. Assume we have a local CocoaPod, which contains source code. And you need to define a Swift package for this, because this is quite straightforward, because if it's a local pod, you have the pod spec, you need to simply convert the pod spec to Swift package. And then you need to drag this into Xcode. Xcode will recognize this folder as a Swift package because there is a package manifest file there. And then you can use it. So, and you may have external CocoaPod. It might not be a Swift package today. If it's a Swift package, then easy, because you just need to specify the URL and use it, because it's a Swift package end of the day. So if it's not a Swift package, and if it contains vendor binaries, so these vendor binaries can be in two forms today. It can be XE frameworks, or it can be good old frameworks. So, but this framework format is not supported in Swift package binaries. Swift package binary support only cater XE frameworks today. So you have to do this conversion and then define a Swift package and then use that package. Interestingly, you can adopt SPM incrementally. You don't need to convert everything to SPM at once, but you can do one by one. So you might have few pods that are already CocoaPod, already Swift packages, which is easier for you to migrate, and you can pick them first and then continue the migration. Let's take an example. So if you have this setup, this is a simple example, right? So you can start one by one. Like you can first, for example, say you want to migrate this Swift protobuf to Swift package. This might be already a Swift package. Then you can remove this from the pod file and do this integration as a Swift package. But you can't pick a CocoaPod that has multiple dependencies into it and then migrate one. For instance, if you want to migrate SnapKit, you can't just migrate SnapKit because it has another transitive dependency into it. So you have to migrate both of them at once in a one go, but still incremental, because you didn't have to migrate everything at once. You could pick one pod at a time or group of pods at a time. That should be your strategy. All right, let's try to understand what Swift Package Manager can't do, its limitations.
Let's look at the limitations. This is really important because before I start using any tool, it is important to understand what the tool can do as well as what the tool cannot do. So let's have a look what SPM cannot do, because uh, when you are deciding to migrate, you can make an informed decision whether these limitations are going to block you or available workarounds are really applicable in your cases. First limitation, mixed language targets are not yet supported in Swift Package Manager. This is unfortunate, but this is the reality. But this is not going to be a big problem for many of the use cases because if there are no interdependencies within a single target, like between C family language code, Objective-C, C++, C, and Swift. So if these are not interdependent, you can simply split them into multiple targets inside a single package. So here is an example from the LL Build project. So LL Build is the low-level build system framework under Swift. So as you can see that they have split these two targets. One contains Swift and the other one contains C++, which can contain C, Objective-C as well. And they have split into the two targets. So this is totally fine. But if you have interdependent files, then you might have to do some refactoring work to split them up so that you can split the targets into multiple targets inside the package. This is one workaround. There is another workaround, which is you can create a C framework and precompile this package. So if you precompile this, because you can precompile using Xcode, Xcode can handle mixed targets, and you create a C framework, and then you publish that C framework as a Swift package, and then you can your clients can use this precompiled target. So that's the second one. The next problem, custom build configurations. So this is more of a common use case that you use a build configuration which is not one of the configurations that Xcode provided by default. So whenever you create a new project, you get two configurations, to debug and to release. But you often create other configurations, for example, testing. And then you use these configurations to have conditionally compiled logic. Like, for example, in the right, you can see that you can make certain functions only available to certain configurations because you don't need to compile test only functions, if you have any, into the binary that you ship to the customers. But the problem is today the Xcode and the Swim integration cannot handle this case because even though Xcode has many configurations, SPM only know about two configurations, debug and release. So if you have these precompiled compilation conditions, then this is going to be a problem. I mean, there is no very good workarounds for this. The next problem, the flexibility with the linking. So if you're consuming a CocoaPod, and if it ships as source code, you can either integrate, you can choose whether to use a dynamic library or a static library. By the way, if you're not familiar with this dynamic and static libraries, so these are two different kind of binaries. So the dynamic library is something you package inside the application as a separate library, and when the application is launched, these libraries are loaded, so your code get executed the code. But static libraries are different. These are kind of a archive file which lists all the symbols. And whenever you link that library to a destination target, it can be either executable target or it can be another dynamic library. These symbols become part of that library. These are not bundled inside. These have become part of the client library. these two has, I mean, there can be different requirements. Like sometimes the client wants to use a static library. Sometimes they might want to use a dynamic library uh, because there are some performance benefits if you don't use extensive list of the dynamic libraries. So because of that reason, sometimes we might need to you consume these libraries as static. But if you check the documentation, it mentions like not to specify the type of this library. So in the right side, you can see a package manifest for the SnapKit. And you can see in the products section, there's a library called SnapKit, but the type is specified as dynamic. So the documentation says don't specify this so that the clients can choose, the Xcode can choose which one to use. But in reality, Xcode doesn't do this. Xcode doesn't offer this flexibility. It always fixes the equation. I'm sure that this might be fixed in a future version because the reason that documentation mentioned that is because it is the expected behavior in Xcode, but Xcode doesn't behave as expected for some reason. So to work around, what you can do to work around this problem. So one thing you can do today is, first of all, as people, you can pre-compile this into Xc framework, either static or dynamic, and then you can use it. Then you have the choice which one to use. So that's the first option. The second option is actually, since they are consumed as static libraries by default, you can create a shim framework inside your project and then link all of them together and use that framework as a kind of a merged entity for all of your frameworks. So this approach has some performance benefits as well compared to consuming all of them as dynamic libraries. If you merge them together in the single library, it reduces the number of dynamic libraries you have, and if it's below a certain amount, it can help the performance of the startup. But that's a different topic. So there are two workarounds for this. One is create a Xc framework or create a shim framework that merge all of them together. And there are some binary framework hiccups in Swift PM. So this number one is this code sign issue. So sometimes keeps to code sign. I mean, if there is a Xc framework that you use inside your project, this binary target sometimes fails to code sign. But there is a workaround for that. You can add a run script to do the code signing by yourself. So it's just execution of a command. By the way, I linked all of these workarounds in the footnote of this slide. It's all of them. And there's another issue, which is if you have a binary framework hosted on an authenticated URL, the CocoaPods, the XPM don't support this authenticated URLs in the latest release, but this fix is merged to the master branch. So if you use the toolchain from the nightly builds, this is available. But if you use the latest release version, this is not available. So you cannot use binaries hosted on authenticated URLs. This is also a limitation exists in the latest release, but fixed in the current master branch. So this limitation means that you cannot have much flexibility that what client wants to download, because you can have a Swift package that has a lot of products. So one package might offer different kind of products. It might offer separate products for tvOS, separate product for iOS, or maybe it can have products that is only needed for testing, this kind of thing. So, but in the current release version, this is not fully implemented to have this flexibility that client can actually choose what they really need to download. The client doesn't need to download everything defined in the package. It can selectively choose which product it wants. I mean, this is only like a downloading problem because when you're integrating it, this is not a problem because, of course, integrating use like what are your dependencies clearly, but when downloading the package, it fetches everything. Let's look at the future. The future of the package manager. The future is exciting. So this is the future for CocoaPods actually. So CocoaPods has done a great job. Of course, it's not perfect, but it has done its job, and it will continue to do a very good job until it is no longer needed. But Swift Package Manager is catching up, and it's filling the gap in an increasing rate to become a whole package, which includes a build system, a way to define and describe a whole project, and the build system behind it actually getting interesting development as well. For example, LL Build 2. So it's an experimental version of LL Build, which actually implement advanced features like remote execution and many others. So this will bring some capabilities that those alternative build systems enjoy today, like executing your build remotely and then download the artifacts so that you can hand over the build operation to a faster machine and you can continue to work on your development while your build happening. And also, this will open the door for reproducible builds, which means that some shared build cache between the machines, which is not something readily available today.
Okay, let's wrap up what we have talked today. So CocoaPods is not perfect, but it has served the iOS community for a very long period of time very well. So big kudos to the contributors, and I'm pretty sure like they will continue to maintain this package manager or the dependency manager as long as it is needed. So we might be migrating away from this, and eventually this will fade away. But let's not be that folks that okay, you have a new shiny tool and then you kind of try to shame or maybe complain for every edge case or every issue that you had with these tools. Let's not do that because these folks find their most valuable asset in creating those tools. So let's appreciate that. It's amazing what these folks have done, and it was an amazing tool, right? So Swift Package Manager fulfill most of your requirement today. So the takeaway from this is make an informed decision. Understand the benefits that Swift Package Manager can bring, and evaluate carefully what it can do today as well as what it cannot do today, and compare those things in your projects, in your app. So if you don't find any blocker and if you see the benefit, go for it, and it's a good time to do it. But if you're blocked by a hard blocker, or if any workarounds for any of the limitations not applicable to you, try to research them, try to ask questions in the forums, try to ask questions in this Swift Package Manager contributor community on Slack or Swift forums, and try to find a solution. So this can be a quite exciting challenge for you to start this migration today. So try SPM and see where it takes your project. So I have linked a set of valuable resources here. So as I said in the beginning, we didn't cover the details of the Swift Package Manager API because there are amazing resources that you can use to understand this package manifests, how to use resources. So Apple has compiled a set of really neat videos for those things. So look at them, and they're very well documented and very well presented. Thank you for participating in this talk, and time for questions.